Hello, welcome. Thank you for being here so early after lunch. And thank you to Linux Foundation Energy for having us, to Alex Thornton for inviting us to speak. My name is Christian, this is my colleague Stephen. We're both OpenSCD developers at OMICRON Energy. Who's OMICRON? We're a manufacturer of power system testing solutions. Been involved in IEC 61850, the standardization process, and interested in the standard from the very beginning. And we've been represented on the working group writing the standard since the early 2000s. And the reason why we're here today is because OMICRON founded the OpenSCD project in 2020. And I'm assuming everybody here in the room already knows what IEC 61850 is, uses it, supports it on their devices or something along those lines. That's great. And everybody has probably also heard of OpenSCD, what OpenSCD is. Then I don't have, or maybe some words might be nice for orientation. So the kinds of things that people might have heard that OpenSCD is, you might have heard it's an editor for SCL files or a web app. You might have heard it's a desktop app. You might have heard it's a system configuration tool, or you might have heard it's not a system configuration tool. You might have heard it's a toolbox for building your own configuration tools. You may have heard it's an LF Energy project, or that it's not. And all of those things have been more or less true at some point in OpenSCD's varied and colorful history. So I want to explain a little bit to you how OpenSCD came to be something like all these things at some point, and what OpenSCD is today, and who's using it today, and what they're doing with it today. You will hear something about after that from my colleague Stephen. The origin of OpenSCD was in some conversations among IEC 61850 engineers at OMICRON. Let me give you a couple of quotes to illustrate what sort of things they might have been saying. There was one engineer at OMICRON who was famous for saying that IEC 61850 system configuration is the valley of death for multi-vendor digital substation projects. They had noticed that the system configuration part of the whole engineering process often causes long delays, is very expensive, takes very specialized, highly knowledgeable engineers a long time to achieve, and therefore is often responsible for project delays, for increases in cost, or even for project cancellations. Another IEC 61850 engineer at OMICRON would always say that the most widely used IEC 61850 system configuration tool in the market is Notepad++. That's a sort of text editor with structural support for editing XML files. And what this engineer had noticed is that often these kinds of tools were needed in addition to system configuration tools if you wanted to use a system configuration tool together with different vendors' IED configuration tools, because there would always be some incompatibilities in the way that different vendors did things in the standard. So the only alternative would be to just stick with one vendor's devices and stay with vendor lock-in, and that sort of defeats the purpose of the whole standard, which was promising interoperability and flexibility and all those great things. So in 2017, this latter engineer saw the need for a single central open source SCL editor tool that everybody could share, that all system operators could use to do their system configuration bottom up or top down, and that would be more user-friendly than just a text editor, an XML text editor with guided engineering workflows and with some validation built in, but at the same time would still allow you to make all the changes that you would need to achieve the goal of a working substation in the end, all the changes you need to make to any part of the file, and had a plugin system so it could be extended by vendors without having to coordinate with the development team for compatibility with different vendors' devices. So you could have devices directly supported by vendors within this central open source SCL editor. And so they started this project, which in 2018 saw its first internal release at OMICRON under the name OpenSCL. And OMICRON engineers were very happy to have this tool in order to improve the quality of customers' SCL files, which often lacked process level elements altogether, no documentation there, sometimes had some mistakes in them. And So OpenSCD, or OpenSCL as it was known at the time, was adopted by OMICRON in 2019 as a tool for that exact purpose. And we were planning an open source release for 2020. Before that happened, there were a couple of things missing in the app, and there were a couple of problems with the code base, so we decided to do a rewrite of the app, which was a Java desktop app before, on the web platform. And this version of OpenSCD, now under the name OpenSCD, was released at the end of 2020 under Apache 2.0 on GitHub. And we soon started getting our first community contributions, getting people interested in the project. And since OpenSCD was OMICRON's very first open source project that we were involved in, we didn't really have the experience with open source community management, with how maintenance is best done in open source projects. We were mainly just working the way we had worked internally before, with all our code in a single repository and everybody making the changes to the same repository, reviewing each other's code. So we, over time, invited contributors from the community to co-maintain our repository together. And then a story developed over the next couple of years where it turned out that the different contributors to the project had different needs, different requirements or expectations, both when it comes to what the product should look like and also when it comes to what the development process should look like. So over time, we much decentralized the development process. We used this plugin system that was originally meant only for vendors to extend the tool, for IED vendors to extend the tool for compatibility. We used this to basically modularly restructure the entire project, to have a very small software core in the middle that basically just orchestrates all the different plugins, and to have all the end user functionality in plugins that could be developed and maintained separately in individual repositories. And even though we did this initially only for these development process reasons and for like these to satisfy different stakeholder interests, it turns out that this made in the end for a much, much more powerful ecosystem where with this new modular architecture, different companies that have different needs can build their own custom tool out of these individual building blocks to achieve the different goals they have and to implement the sometimes very different engineering processes that they may have, especially for system operators. So one thing to mention within the history is that throughout this decentralization process, we also had some different ideas in the community about how the decentralization could work. So for a while in 2023, the development community split up into one half of the community which was trying to do the centralization within the existing repository and only tear the code apart in the end, and another group of contributors which were doing a modular architecture from the start and transferring one plugin at a time. But nowadays, there's full compatibility again between all the different versions of OpenSCD. They can use each other's plugins, and we're in the process of bringing these two strands of development together again. And another thing to mention, because you may have heard that OpenSCD is an LF Energy project, is that from 23 to 24, we had some conversations with LF Energy about potentially donating the project. But at the end of 2024, that sadly fell through due to legal reasons. OMICRON wasn't able to donate the trademark to LF Energy, and that was a reason for not being able to adopt the project into LF Energy. And that's a really good place for me to say once more a big thank you to Alex Thornton and to LF Energy for still so warmly embracing the OpenSCD project, even though we're not officially an LF Energy project. Of course, we still collaborate closely with the Compass project, which is LF Energy's system configuration tool consisting in a fleet of microservices, where Alliander have decided to use OpenSCD as a front end. And we're still happy to have this close collaboration, even though OpenSCD officially is not an LF Energy project. So that's how it came to be that OpenSCD, from a single central app with a couple of plugins for vendor compatibility turned out to become this ecosystem that a community of different companies with different interests can now use to solve their problems. And who's using OpenSCD today and what they're doing with it, you will hear some about from my colleague, Stephen Renwick.
Thank you very much. So, OpenSCD, who's using it today? Well, we know of system operators using it, and there's even some IED vendors getting involved now, creating some IED configuration tools. Of course, OMICRON, we're using that internally, and but today I'd like to showcase a few companies who are using OpenSCD in different ways. And the first one being Transpower New Zealand. So Transpower New Zealand are a national TSO the national TSO for New Zealand. They needed a tool to support their engineering process for a digital multi-vendor substation. And after evaluating a variety of existing vendor tools and system configuration tools, they found that OpenSCD provided the flexibility and to build an SCT tool which would complement their engineering process. I'd like to quickly go through how a third-party engineer might use this tool to configure or design such a substation. Typically, this begins with using the IED template importer to import some of the Transpower IED templates, and begin to draw a substation using the single line Transpower single line diagram editor. Here you can see the single line diagram plugin that Transpower developed. The bay templates are used to add in as many bays as is required, and you can also see that they've also included the IEDs, these small little things here, the IEDs, and they've positioned all of them. We're going to see later on how this comes into play when displaying the communication. I'd also like to point out that all of the artifacts you see here are in fact represented as SEL elements. That's to say, if I was to click on the blue button and add another bay in here, I would actually get an SEL bay element in my file. Also, additionally, the diagrams that the engineers design here, they can be exported as SVG files to be used in other tools, which is also very handy. So, we have our IEDs, we have our bays, everything's in place, hopefully wired up correctly. The next step is to set up the subscriptions. Now, for the subscriptions, Transpower could have used the existing plugins to manually configure the subscriptions. But what they've decided to do is they develop their own plugin and take this to a whole new level with what they refer to as the stencil plugin. Now, the stencils that you see down here, these are pretty much a pattern of communication between a group of IEDs. And the role that each IED plays in this pattern, they refer to here as functions. So the engineer would simply select the stencil they wish to apply, and for each one of the functions, they would bind it to one of their IEDs in their design and apply it. And I don't know if you can see that there, probably not, but in this example here, 53 subscriptions and 28 supervisions were done with a single click of a button, and it's with 100% accuracy. So this is a real big success story for Transpower. There was an engineer from Fortescue who's also using this plugin, is quoted as saying, "This is the way IEC 61850 is meant to be." So they're really delighted with how this is working. So we have our diagram complete. We have the communication or the subscriptions all in place. We've gone through all the stencils that we need. Now you can see how this is all represented nicely in that previous diagram where the IEDs are in place, and now you see the lines of communication between each of the IEDs that we've just set up. So after that's done, the addressing can be addressed with the communication or the communicate plugin. You know, the access points can have their IP addresses and whatnot set. But Transpower again didn't stop at that, and they also created a plugin to automate parts of the addressing, multicast goose and sampled value messages and VLAN allocations here. And as if that wasn't enough, they went and developed another plugin to generate the configuration files for the Cisco switches based on the information in the SCL file. And last but not least, Transpower developed a plugin, the state-of-the-art semantic comparison tool. And this tool is an awful lot more powerful than your typical text-based or XML structured comparison tool. Engineers can choose from a set of predefined comparison rules, allowing them to semantically compare even large files, and brings their focus in on the parts that matter to them. So that's it for our high-speed tour of Transpower. I would encourage you to have a look at the distribution yourself and see what I have quickly skipped over. The links will be at the end of the presentation. The next company I would like to showcase is Alliander. You may have heard of them. Alliander are a distribution system operator, and they're using the Compass configuration tool. So they've used OpenSCD as a graphical front end for their Compass-based solution. Here you can see they've integrated a single sign-on into their solution to provide access to the Compass microservices, such as opening files directly from the database and creating or comparing versions of the SCL files saved in the Compass database, even importing a CIM file in to start the specification process. Here you can see the single line diagram viewer that they developed, and this has got a really cool feature where it'll automatically lay out the substations for you. You just simply select the different substations, and boom, your substation is accurately laid out for you. It's hard to see here, but you can trust me, it's correct. So incidentally, I'd like to point out that the coordinates applied in the SCL file are using the standard SXY coordinates recommendation in Appendix C of the IEC 61850-6 specification. So they've also included the template generator plugin. This is a guided generator for creating valid data type templates. This is very useful for the top-down engineering process during the specification phase for creating new data models in line with the IEC 61850 namespace descriptions. And of course, they have the template data type editor, allowing engineers to add and remove and change practically anything in the data type models. But thankfully, Alliander have also included validators that run in the background. So when an expert makes a small boo-boo, they can quickly undo that, saving their reputation. So that's all I have time to show you on the Alliander's configuration tool. I really encourage you to go and have a look at this awesome tool yourself and take a closer look at what these guys have achieved. So the last company that I would like to show you is not a system operator, but an IED vendor. Meinberg is the first manufacturer of P2P grandmaster clocks to directly support IEC 61850. Instead of writing their own tool from the ground up, Meinberg used OpenSCD. Using a small set of existing plugins, they were able to achieve practically everything that they needed. To complete the picture, they only had to develop one single plugin. And on the side, they decided to rewrite another. So here you can see their version of the IED editor. They actually rewrote the UI on this because the existing IED configuration didn't have the nicest interface in the world. So they decided to rewrite it. So for that, we say thank you, Meinberg. The rest of the configuration is using standard plugins, some of which we've already seen, so I'm going to skip over them in the interest of time. Meinberg developed a menu plugin which can be integrated into any OpenSCD-based tool to extract a single IED editor, a single IED configuration from a larger SCD file and to upload it onto one of their devices. The engineer simply selects the relevant IED, and with CID selected, they just export it. So that's it. So we've seen three different companies, or three different examples of how companies have used OpenSCD to meet each of their needs. If you know of other companies using this in other novel ways, we'd absolutely love to hear from you. Oh, excuse me. If you're already using OpenSCD, but you haven't been in touch with us, we would actually love to hear from you. So please get in touch. You can get in touch with us here at the Zulip link. And of course, if you're not using OpenSCD and you are interested in OpenSCD, we're interested to hear from you. So please find us, track us down. If you don't succeed, you can again go to the Zulip link down below. Or I would also encourage you to go directly to openscd.org, where all of the distributions that I've just shown you are all linked, so you can go and play with this stuff yourself. And on that note, I would say thank you very much for your attention, and enjoy the rest of the summit.
And we actually still have quite a bit of time left for questions. So yeah, if anybody has any questions, we're happy to answer.
Hi, Marco Donofrio from KU Leuven University.
Hi, Marco.
So it was quite interesting to me the moment you showed the plugin, if I'm correct, that does a semantic comparison. What do we mean here by semantic? Because it's, I would expect.
Is the question? Sorry, is the question? What do you mean by semantic?
Yeah, because I would expect like such a tool to do a syntactic comparison easily, but.
Yes. Yeah. So a syntactic comparison is easy. Of course, SCL syntax in principle is defined in terms of XML syntax. Now, the thing with SCL is, for better or for worse, it's a very flexible standard. So it allows you to represent the same sort of state of affairs in many different ways. So there can be two different SCL files that look very different structurally on the surface, but when you apply them as a configuration to a substation, the two substations in the end will work exactly the same. This goes from simple examples like whether you set the default value for a particular data attribute somewhere directly in the data type template section, or whether you set it directly in the IED, in the instance of the data attribute, to other things where, for example, a server can either be copied to have the same server twice into access points, or it might be a reference where the server is at another place, or even simple XML reformatting things that just don't make a difference to the meaning of the file. So what we're trying to do in this diff plugin, in this comparison plugin, and of course it's an ongoing process, getting more detailed into the semantic model of SCL, but what we're trying to do is represent the difference between the meanings of the elements. Like, for example, if you have one file in which a server is copied into 2 different access points and another file in which the same server is just referenced from the second access point, you won't see any difference between those files. You won't see that showing up as a difference. Unless, of course, you say in your rule set, that's why it's configurable for different purposes. Some things count as differences and other things don't. You specifically say that you want to see that as a difference. So that would be an example. Does that answer your question?
Yeah, thank you. That's very interesting. I think that's the hard part about.
Yeah, that's the hard part, exactly. Yeah, that's why Transpower were very adamant on having a really working comparison tool. It wasn't working for them doing XML text comparison. Yeah.
Thank you.
More questions? Thanks. Well, then also thank you from me for your attention, and see you later.